Alrighty, in this video we're looking at adding and subtracting fractions. But again, just like my equivalent fractions video, rather than just showing you what to do, I'm going to show you why it works. And then I'll show you what to do. I think that background knowledge of why it works is really important, because if you forget how to do it, you'll hopefully remember why it works and then figure out how to do it from why it works. At the very least, you'll have an understanding of why what we do, which I'm going to call cross multiplication, why that works. Okay? So I've got two things that I need to establish with you first. The first thing is, if we times a number by 1, it equals itself. So for example, example 1, 4 times 1 equals 4. Timesing by 1 doesn't change the original number. If I take a number in algebra, perhaps like x, and I times it by 1, I get x. Nothing changes when I times something by 1. Okay, that's the first thing. The second thing is, if I divide a number by itself, I get 1. So 4 divided by 4. In other words, how many 4s are in 4? There are 1. Also, if I take x again and do x divided by x, I get 1. Anything divided by itself is 1, and anything times 1 is itself. Okay, they're two really important concepts, because now when I look at this example, finally example 3, which is going to demonstrate this addition concept of cross multiplication quite well. Hopefully that helps us with this. So I'm going to do it underneath, so hopefully I'm not drawing all over my body here. I'm going to create a fraction, a pretty simple one. Let's go with 1 over 2 plus 1 over 3. Okay, and what I'm going to do here is I'm going to times both of them by 1. Remember what happens when I times something by 1? When I times something by 1, it equals itself. So if I times this by 1, it equals a half. And if I times this by 1, it equals 1/3. And so I haven't actually changed anything in the equation. I hope that's clear. The other thing I want to do is times it by 1, but in the form of a fraction. Like 4 over 4 is 1. If I times this by 4 over 4, it's still a half, but it'll look different. And that's good for us. So I want to times them by 1 in the form of a fraction, but a specific one. I'm trying to get these two denominators to be the same. If the denominators are the same, I can just add the numerators. I can't right now just add 1 plus 1 equals 2 over 2 plus 3 is 5. It's not the same thing. So I'm going to times this one by 1, but in the form of 3 over 3. I hope based on this rule here, you'll agree that 3 over 3 is 1. And so when I times a half by 1, it equals a half still. Okay, that's going to turn this into 3 times 1, that's 3. And 3 times 2, that's 6. I'm also going to times this by 1, but in the form of 2 over 2. And if I do that, I get 1 times 2 over 3 times 2 is 6, and you'll see nicely now we have a common denominator, we call it. A common denominator, meaning I can just add the numerators together and put them over 6. And so finally the answer to this equation is 3 plus 2 is 5 over, well, the common denominator of 6. And 5/6 is the answer to 1/2 plus 1/3. Okay, now if you'd like, by the way, you can just do that every single time. But I've found in my experience a lot of students don't really like that. They don't like it as their main strategy because it's a bit time consuming. However, it is the background for cross multiplication, because what you'll see we've done, to make these both 6, we've times these two numbers together. That's good. So 2 times 3 is 6, and in both cases they're 6. But what we've done to the two ones is we've times this one by 3. See, we've got 3 times 1, so it's this one times 3. and this one here is times 2, or 1 times 2. So we get this thing called cross multiplication. I'm going to demonstrate it over here. It makes this process just a bit faster and less messy. Maybe more messy, but it's faster for sure. And a lot of students love that. So looking over here at this example, 1 over 2 plus 5 over 6. What I'm going to do is I'm going to say that's going to be equal to, the denominator is going to be 2 times 6. Okay. Now, by the way, for those who are really good at fractions out there, I acknowledge that 2 times 6 is not going to create the simplest fraction, but I will simplify it later. So 2 times 6 is 12. That's my first step, is going to be multiply these two numbers together. And once I've multiplied them together, I need to do cross multiplication. So I'm going to multiply 1 and 6 together, and I'm also going to multiply 2 and 5 together. Okay, so I'm going to deal with this 1 first because it's on the left. So I read left to right, so I'll write left to right as well. 1 times 6 is 6, and 5, and we've got a plus in the middle here, so I better chuck that in. And I've got 5 times 2, that's 10. Okay, so I get 6 plus 10 over 12. I might simplify that though. So 6 plus 10 is 16, 12 is 12, and I'm not quite done. I can simplify that a tiny bit more. I have a common factor of 4 that goes into both of them. So I'm going to divide both of them by 4. That's 4, and that's 3, 4/3, and finally I better change that to 1 1/3. Put it as a mixed number there. This process of simplification, check out my equivalent fractions video if you're unsure of how to get from here to here. I haven't quite yet done by the time I release this video, I probably have done a converting between improper and mixed fractions video, so look out for that one, for this step to this step. But the main thing I want to show you here is if we times the denominators together, they make 12, and if I do cross multiplication, we call it, I get 6, because 1 times 6 is 6, and 2 times 5 is 10, and it was originally a plus, so I put the plus in there, add them together, and you get 16/12. This one here is a subtraction rather than an addition, but it's the same process. The only thing that differs is that this sign won't be a plus, it'll be a minus. Okay, so let's go ahead and have a crack at that. I'm going to say, I'll just work down the page, if I've got enough room. Yeah, I should have enough room. I'm going to multiply these two together. So 9 times 5 is 45. So my denominator is going to be 45. Probably need a longer vinculum there. Yes, fun fact, that's called a vinculum. Okay, now I'm going to do cross multiplication. So I'm going to do 8 times 5. 5 8s are 40. And I'm subtracting, need a longer vinculum than that, 9 times 2. 9 times 2 is 18. Alrighty, do I have enough room down here? I suspect I don't, so I might work across the page here. 40 minus 18, now that I have a common denominator, is going to be 22. So 22, I don't know about you. And 22 over 45. Now, I need to see if I can simplify that. 45 has factors of 1 and 45, not 2. 3 and 15 goes into that, but neither go into 22. 4 doesn't. 5 goes in 9 times, but neither go into 22. 6 doesn't go in, and 7 doesn't go in. So, and neither does 8. So I think we're done. 2, I probably should have started with that. It's only got factors of 1 and 22, which don't go into 45, and 2 and 11. And both those don't go into 45, so that's as simplified as that fraction gets. Oh, I also didn't show this, but of course I did 9 times 2 to make this 18. All right, so the process. Multiply the bottom two numbers, the two denominators together to get your common denominator, and then do cross multiplication to get your new numbers that you're either going to add together or subtract from one another, depending on what your symbol is. Hope this one helped, and I'll see you in the next one.